All right, we got Module 1, functions and their inverses. So the first thing that we're going to be looking at and basically recapping on is the 5 properties of inverses. So let's look at them. So first, when it comes to the equations, to find the inverse equation, we solve for the other variable. Okay, so isolate the x pretty much. And then when it comes to the t-charts or the t-tables, the domain and the range swap. So basically the x values are going to swap with the y values. Okay. Next, when it comes to the properties of inverses, they're graphs. On the coordinate plane, the y equals x line, which is a diagonal line that crosses through the origin, okay, their graphs will be reflected over this line. Next, the notation and how we write an inverse is just with this -1. And then the last thing, when it comes to compositions, and a composition is basically when we substitute one function inside of another function. So when it comes to inverses, if we were to take the inverse of f, basically, and substitute it into the f function, everything will eliminate except for just x. Okay, and so vice versa, the same thing works. So these are the 5 properties of inverses. Keep that in mind, and also keep that in the back of your mind as you guys are doing this final. So let's dive right in. So number 1, it's giving you compositions. You can tell because it's saying, okay, take the f function and put the g function inside. So I see the f function, which is 2x to the 4th. Now I'm going to replace the x value with the g function. So it's going to look something like that. So the 3x to the 8th is on the inside. Now, whenever I'm raising something to the power of 4, that means we're going to be basically taking this 4th power and taking x to the 8th to the 4th power, and then 3 to the 4th power. So 3 to the 4th power is 81, and then 81 times the 2, that's going to give us the 165, and then 4 times 8, that'll give us 32. So that would be the answer for that one. Okay, next one, we got to take the h function and put it inside the g function. It's going to look a little bit like that. I got to take 8 and raise x to the 6th to the 8th power, so we're multiplying there, and the 3 just stays on the outside. Next one, f of x is going inside of h. H is just whatever it is to the 6th power, so I basically just have to take the f function and raise it to the 6th power. The 6 goes to the 2, don't forget about that, as well as the x to the 4th. So I have 2 to the 6th power, which is 64, and then the x to the 24th. All right, number 2. Now we're not really doing what's called a composition. We're now doing function operations. So don't think that this x means we have to multiply x by whatever we get. It's just kind of like up here. See how it says f of x? So this x on the outside in parentheses just means of x. So we're going to take f plus g of x. So I'm going to take the f function, add it to the g function of x. So it just looks like this. Okay, and since the bases are the same, typically we can combine these as long as the powers are the same. Okay, and these powers, this is 3 times x, and this one is 4 times x. So if we give a value to x, like let's say 1, we can see that these powers are not the same. So I want you to think about it kind of like this. If I had x squared plus x to the 4th power, do you see the bases are the same, okay, but the powers are not the same. Therefore, we can't combine those. So this is it. This is as far as you could go with A. And in a similar sense, that's as far as you could go with B as well, because you're just subtracting, and the powers are not the same. Now, when it comes to multiplication, we can combine them if the bases are the same. So if I take f plus g, times g, I can take the powers and add those together. That would give me 8 to the power of 7x. Okay. Next, when it comes to division, we can actually combine these. So this is 8 and that's 8. So what we do here is we subtract this. So this would be 3x minus 4x, which would give us negative x. And typically we don't like negative exponents in our simplified answer. So we're just going to take the reciprocal. So that's how you do that. All right, next couple questions. They look really intense, but they're not that bad. Okay, so it gives you a function f, and then it gives you a function g. And it's telling you to multiply f times g. So we're just going to do that. Okay, we're going to take f and g and multiply them together. Okay, this is f times g. Now notice that it tells you in relation to time, it says after 5 years. So it's talking about 5 years. So we're going to take this t and replace it and substitute a 5 in there. And then just simplify. Okay, and it says round to the nearest dollar. which I'm not sure if I did that on this PowerPoint. But anyways, so I'm going to raise this to the 5th power. Remember, we can't multiply before we do the power, so it's 1.05 to the 5th power. You're going to get a decimal, and then multiply that times 1,000, and I ended up with 1,276. Okay, try that on your calculator, see if you get it. Next, it says a scientist is working with a type of bacteria. All right, so it gives us the formula where we have 1 times 2 to the power of b, and then it says where b is the time in minutes. Okay, and then it gives us the value for minutes. So we have the equation. We're going to replace the b with 5. So actually this should be a 5 right here. And then we're just going to simplify this. So 1 times 2 to the 5th. 2 to the 5th is 32. So then we know that after 5 minutes, it's going to be 32. Next, it says a student is asked to verify a composition. Okay, so remember, composition is when we take one function and put it into the other. So it looks like it's, okay, so we're going to take this function, the 3x minus 2, and put it, this g function inside. So it looks like we're looking which step contains an error. So let's see if this person did this right. So they took the f function, and then they're substituting in x plus 2. Wait, where did they get the x plus 2 over 3? Oh, g of x, that's where it is. Okay, so they're taking the f function, there it is. Okay, g of x is going in. So there it is, that's in there, and that looks pretty good. And then step 3, let's see what they did. So that x now has a 3, so that means they distributed that 3, and they put it up to the top, and then they still have it divided by 3. And then 3 times the 2 would be... Okay, so that's, I think, an error right there. And then I don't know why they... Oh, okay, so look. See this 6 on the outside? It looks like they might have distributed the 3 times that as well. Or what are they doing? Yeah, because that would be 9 over... Oh, I'm sorry, 6 over 3. That's that guy, but it shouldn't be subtraction. Okay, so I think their error is in step 3. Okay, they made some distributed property error. So that's how you do that. Okay, next it says Maggie claims that a function, this, is the inverse of the other function. Is she correct? So there's a couple ways that we can verify this. We could use any of those properties. We can solve for the variable. We can do a composition and see if it equals the x. We could graph it and see if it reflects over the y equals x line. I think I'm just going to do a composition. So let's take the g function and let's put the f function inside. So if the g function is this, if I replace the x with the f function, which is the 3x plus 4, let's see what we get. So this is 3 over 3, and this is 4 over 3. Okay, so 3x over 3, and then 4 over 3. Now, is that going to simplify to equal x? I mean, this will be x, this will be x, but then I don't think these two things will subtract out and cancel. So then it's not equal to x, therefore, is she correct? No. Alright, next, this chick is, okay, so she's got a graph, and she is then asked to find 2 points on the function g of x, in, which is the inverse of f. Okay, so here we're looking at the property where it should be kind of basically reflecting over the y equals x line. So what I would do, let's say, okay, so she says that the point 1,4 is on the inverse. So I would look at this and be like, okay, where's 1,4? 1,4 is right here, and that's on the f of x function. So there's no way that 1,4 could also be on the inverse of that function because we swapped the x and the y values. So what should be on the g of x function is 4, 1. So there's no way. There's no way, basically, that 1,4 can be on g of x because the domain and range swap with inverses. So there's no way that they can have the same point. They can have the same point if it was like 2, 2, or 3, 3, or -4, -4. That would work, but not in this case. All right. Next, it says a certain function g of x is comprised of 8 different points that are shown below, and it gives a bunch of points. Okay, then it says the inverse of g is not a function. Which 2 points should be removed from g of x? Okay, so first thing we need to do here is understand what is a function. What makes a function a function? So number one, functions, the x values must not repeat. They can't repeat, okay? It needs to pass the vertical line test. All right. Next, we know that when it comes to inverses, the x values swap with the y values. So basically, we're looking at all these ordered pairs, and if any of the y values, which will soon be the x values for the inverse, if any of them repeat, then that means that we're going to have an issue, and it won't be a function. Okay, so it says which 2 points should be removed. So looking at the stream of ordered pairs, are there any y values that repeat? Because if they repeat, then that means when I do the inverse and swap the y values with the x values, then they will not follow the rules of functions. So I see a couple y values that repeat. So I got -3 and -3, 2 and 2. So basically, if I just eliminated these first two, then it would be a function, okay? Or if I eliminated these two in the back, or any of these, two of any of these four, which I just highlighted, that would make this answer work, okay? So it doesn't necessarily have to be the first two. It could be these two or any order in which you want to line those up. Alrighty?